Hello, viewers. In today's session, we are going to discuss another important and conceptual problem from limits. And here we are going to discuss this problem where we have to find the right hand limit and the left hand limit of this function, which is a combination of greatest integer function and the fractional part function, right? So here the square brackets denotes or represents the greatest integer function, and the curly brackets represents the fractional part function. So we have to find the right hand limit and the left hand limit of this function f of x, that is equal to 2 times the greatest integer of x minus 3 times the fractional part of x when x approaches to 0. So before finding out the right hand limit and the left hand limit, let us quickly see the notations. And here, if we have a function, say y is equal to f of x, which is defined in some domain, say D, right? And suppose we have to find out the right hand limit and the left hand limit of this function at some point, say x is equal to a in the domain of the function f of x. So the notation for the right hand limit is given by limit x tends to a, and here we put a positive sign, and here we have f of x, right? And then we take x is equal to a plus h, where h is infinitesimally a very small quantity, right? And h is greater than 0, that is it is positive, and h lies between 0 and 1. So here to get the right hand limit, we have this notation, and then we take x is equal to a plus h. So here when x approaches to a from the right of x is equal to a, then h tends to 0, right? So we have now the right hand limit in terms of h, that is limit h tends to 0, and here we have f of x. For x we can write a plus h, and similarly if we have to find the left hand limit, then the notation it goes like this: x tends to a, here we put a negative sign, we have f of x, and in this case we take x is equal to a minus h, where h is infinitesimally very small, h is positive, h lies between 0 and 1, and when x tends to a from the left of x is equal to a, then h tends to 0, and we have now limit h tends to 0, and here we have f of a minus h. So here we are going to make use of these two results to get the right hand limit and the left hand limit of this function when x approaches to 0. So here our function y is equal to f of x is given by this expression, and here x tends to 0. So the value of a is equal to 0. So here we have the real number line, and here we have the point, say x is equal to a, right? And here we have minus infinity, here we have plus infinity. So when we find out the right hand limit, we take x is equal to a plus h. So here towards the right of x is equal to a, we have this point as a plus h, right? And towards the left of x is equal to a, we have this point, that is a minus h, right? So here in this case we have a is equal to 0. So we can now write our function f of x is equal to 2 times greatest integer of x minus 3 times the fractional part of x. So here we are going to make use of the relationship between the greatest integer function and the fractional part function. And we know that the domain of the fractional part function is the set of real numbers, and the range is given by 0 to 1, right? So here the fractional part function is defined as x minus greatest integer of x. So the definition of a fractional part function is given by x minus greatest integer of x, that is the difference of x and greatest integer of x. So let us substitute this value in this function. So we have now the function f of x 2 times greatest integer of x minus 3 times we have x minus greatest integer of x. So we can now write 2 times greatest integer of x minus 3x, and then we have plus 3 times greatest integer of x. So we can now add these two quantities. So we have 5 times greatest integer of x minus 3x. So the simplified form of this function is now given by this expression. So now for right hand limit, we have this notation, that is limit h tends to 0, and we have f of a plus h. So a is 0, so we have here 0 plus h, right? So we can now write limit h tends to 0, and we have f of h, and here we have taken x is equal to 0 plus h. So we have x is equal to 0 plus h, that is equal to h. And when x approaches to 0, then h tends to 0. So now we have here limit h tends to 0, and f of h can be written by replacing x by h. So we have here 5 times greatest integer of h minus 3h. So now we have this limit, and here we have greatest integer of h, and we have just seen that h lies between 0 and 1. So when h lies between 0 and 1, then the greatest integer of h is equal to 0 due to the definition of greatest integer function, right? So here this term is 0. So this term is 0, and we can now write limit h tends to 0, and we have 5 times 0 minus 3h, and we have now here 0. So we are left with limit h tends to 0, and we have minus 3h, and we can now write minus 3 in front of the limit notation, and we have limit h tends to 0 and h, and this limit is equal to 0. So we have minus 3 times 0, that is equal to 0. So the right hand limit of this function when x approaches to 0 is equal to 0. So we have the right hand limit is equal to 0. So now let us find out the left hand limit, and the notation for left hand limit is given by limit h tends to 0, and we have f of a minus h. So here we have a is equal to 0. So we can now write limit h tends to 0 f of 0 minus h, that is limit h tends to 0, and we have f of minus h. 0 minus h is minus h, and here we have x is equal to a minus h, that is 0 minus h. And when x approaches to 0 from the left of x is equal to 0, then h tends to 0, right? So we have now limit h tends to 0, and f of minus h can be obtained by replacing x by minus h. So we have 5 times greatest integer of minus h minus 3 times minus h. So we can now write limit h tends to 0, 5 times greatest integer of minus h, and here we have plus 3h. So now here we have greatest integer of minus h, and from this inequality we have h lying between 0 and 1. So if we multiply this inequality by -1, we have here 0, then the direction of the inequality gets reversed, and we have minus h is greater than -1 but less than 0. So here we have 0, here we have -1, and here we have 1. So minus h is greater than -1 but less than 0. So it lies somewhere between -1 and 0 but close to 0, right? So here the greatest integer of minus h should be equal to -1 due to the definition of greatest integer function. So we have now here limit h tends to 0, and we have 5 times -1, and here we have plus 3h. So we can now write here -5, and then we have here 3 times a limit h tends to 0, and here we have h, right? And limit h tends to 0, h is equal to 0. So here we have -5 plus 3 times 0, that is -5 plus 0, that is equal to -5, right? So the left hand limit is equal to -5, right? So here we see that the right hand limit and the left hand limit are not equal to each other. That is the right hand limit is not equal to left hand limit, as 0 is not equal to -5, right? So the limit of this function when x approaches to 0, it does not exist, because we know that for the existence of limit of a function at a given point, the right hand limit and the left hand limit both exist. They should be finite, and moreover the right hand limit should be equal to left hand limit. But in this case the right hand limit is 0, left hand limit is -5, and both the limits are not equal to each other. So the limit of this function when x approaches to 0, it does not exist.